done another question on this that doesn't contain a trigonometric function. It's very similar. It's exactly the same thing, except for you're going to be integrating or playing around or differentiating with a trig function. So the first thing to do is represent this as dy dx plus px y equals qx. So we are going to get all we're going to get the dy dx by itself. We don't want this nasty x next to it. So we're going to do some rearranging. So firstly, we're going to move the y to this side, divide both sides by x, and then we're going to bring back over y over x. So that's then going to look like dy dx plus y over x, which equals sine x over x. So now we're going to multiply through the integrating factor. The integrating factor is, let's say, mu x, which equals e to the integral of px dx. So that is the same as e to the integration of, you just look at the px, not the y, so that's 1 over x here. So you're going to have 1 over x dx, which is going to be e to the ln x, which is just x. So now you multiply everything through here by x. So that's going to be x, x, x. So you're now going to get x dy dx plus y, which equals sine x. However, this left-hand side is a little cheeky because it's essentially the product rule in disguise. So we can, because if we know that, d over dx uv equals u dash v plus uv dash, we know that d over dx xy equals d over dx x dot y plus, well, actually that should be in brackets, plus x dot d over dx y, which is the same as 1 dot y plus x dot y, which equals y plus, differentiated, plus x y dash. So this is a little bit of a tangent, but I'm just essentially doing the proof as to why this is about to change in a minute, because sometimes when this goes to just the next step, people don't really understand why. But this is just the proof of why this left-hand side can be changed seemingly drastically, because it goes d over dx xy is xy dash plus y. So therefore, xy dash plus y would just be d over dx xy. So now this left-hand side becomes d over dx xy, which equals, what's the right-hand side? Here, sine x. So now we're essentially ready to do the final step. Final step is we integrate the left-hand side of d over dx xy dx equals the integration of the right-hand side. So we're going to get sine x. So this integrated, you're just integrating this in terms of x, of dx. So obviously that d dx is going to disappear. You're not going to, do a partial integration of just x or something. You forget that. So this would then be xy, which equals minus, this is going to go to cos x plus c. Little side quest again. Sine x cos x minus sine x minus cos x. You differentiate to go down, you integrate to go up. So obviously this integrated will just go all the way back to the top again. So you go up to integrate, down to differentiate. So if you're at cos x, it becomes sin x. Probably know it, but I remember my mind was blown when I was at university trying to remember this. So anyway, you've got this. Let me just box that off, ignore it. And now let's get it in terms of y. So the last step is going to be y equals minus cos x plus c all divided by x. So now we have solved, got an equation for the trigonometric function, which is a first order linear ordinary differential equation, and that's your solution.